So today we are going to learn another technique in image compression, that is psychovisual redundancy. So a human eye does not respond with equal sensitivity to all the visual information. Certain information simply has less importance than other information in normal visual processing. So human eye is more sensitive to the lower frequencies than to the higher frequencies in the visual spectrum. So it can be eliminate all those information for which the human eyes are not sensitive. Those information can be eliminated without significantly impairing the quality of image perception. It is the elimination is possible only because the information itself is not essential for normal visual processing, since the elimination of psychovisual redundant data results in a loss of quantitative information. It is commonly referred as quantization. So this type of technique is also known as lossy compression, since we are going to lose some information that cannot be retrieved. So certain information has relative less importance for the quality of image perception. This information is said to be psychovisual redundant. Unlike coding and interpixel redundancies, the psychovisual redundancy is related with the real quantifiable visual information. Its elimination results in loss of quantitative information. However, psychovisual, the loss is negligible. Removing this type of redundancy is a lossy process, and the lost information cannot be recovered. The method used to remove this type of redundancy is called quantization, which means the mapping of a broad range of input values to a limited number of output values. So, for example, you can see in this figure that is represented by a 8-bit that have a 256 gray level, while this image is represented by a 4-bit or that have a 16 gray levels. You can clearly see that there is a false contouring in this image. So quality of the image has been degraded. So the compression ratio is 2 is to 1. This is another one image. Those are obtained. These images are obtained with the help of certain compression techniques, and the compression ratio remains the same. So I'm going to give you an example that what are those techniques from which we can obtain these kind of compression. So for example, we are choosing a technique that is known as IGS code. So IGS code, in the case of IGS codes, for example, in this table we have a pixel, gray level, sum and IGS code. For pixel value I minus 1, there is a no gray level. So sum is also 0 and IGS code is not applicable. For the pixel I, the intensity value is 0110 and 1100. So this one is an 8-bit. And sum is with this value plus the previous value. So now we are going to add this one. Since here every element, every pixel is 0, so sum will remain same. And now in the case of IGS code, we are only considering the four most significant bits. So these most four significant bits are considered in the case of IGS code. Now similarly for I plus 1 pixel, the intensity value is 1001011. Now for the sum we are going to add this one with this. So we will get 10010111. Now again we are using a same 4 most significant bit. So this is summation, and the four most significant bits are 1001. Similarly for I plus 2 pixel value, the intensity is this one, so we are going to add this one and this one, and finally we are going to get The four most significant bits are 1, triple zero. Similarly, for the throughout the image, we are going to do the same process. As again, you can see in this example that the compression ratio for the 4 bit is 2 is to 1, and for the again for the 4 bit, but with the use of IGS code, the false contouring has been removed.